Hello everyone. Today let's solve the problem Mr. Kitayuta's colorful graph. So you can read the entire problem. They have clearly mentioned the problem statement along with the example. So they have given the input also that should contain the desired output. So they have given two examples over here. You can completely read the problem and I'll just summarize the problem so that it is easy to understand. So just give me a second. So here, what is the problem statement? We are given an undirected graph with n vertices or nodes and m, this one, edges. So just give me a second. M edges. So we have n nodes. We have given an undirected graph with n vertices and m edges. So each edge has a color. Nothing but here each edge has a color. So that's what we have to keep in mind. And for each query, we need to determine how many distinct colors connect to given vertices either directly or indirectly. So what we have to determine, how many distinct colors connect to given vertices either directly or indirectly. That's what we have to determine. So mainly this involves checking if the vertices are part of a connected component formed by edges of the same color or not. So this is the main question they have asked. So let me delete this one. So let's discuss the approach. So as usual, first step, we will be going with the input handling or input reading. So I'll just give input handling or input reading. By this time, we will be knowing the input readings. This just belongs to the JavaScript or the Node part. So while writing the code, you'll get to know. So let's come to the second step, main logic or the core logic. First, what we need to understand, we need to understand the graph representation. So we will be storing the graph as an adjacency list separated by each color. So each color has its own subgraph. So this one we need to keep in mind. So first one is that we are storing the graph as an adjacency list separated by the color. So each color has its own subgraph and edges of that color are stored as connection between the vertices. So nothing but this will be graph representation. So this you will get to know while we write the code correctly. So just remember, we are going with a graph representation where we are making use of the adjacency list that is separated by color and each color has its own subgraph, right? So these things you have to remember. So next, after doing this, for each query, we need to check if two vertices can be connected by edges of any particular color. So that's what we need to check, right? So for each query, we are checking if two vertices can be connected by edges of any particular color. So query, this is nothing but the checking for query connection. I can write CQC. So this is the third step. So what will be the fourth step? So this one is search for connectivity. Nothing but for each color, we'll be making use of depth first search. So just remember, for this particular problem, the main approach that we will be going for here is depth first search, nothing but the DFS. So here for each color, we'll be making use of DFS to see if there is a path from starting vertex to the end vertex using only that color. So for each for each color, this is nothing but searching for the connectivity. So I'll just write here, search for connection or connectivity. So I'll just write CON, that's fine. So for each color, we will use DFS to see if there is a path from starting vertex or starting node to the end node using only that color, using only that particular color. So we'll be checking that one. So after searching, what we will do, we have to count, right? How many such things are connecting, how many such vertex are connecting of same color are connecting to the this one different nodes, two different nodes. Nothing but we are counting the colors. If a path exists for a given color, then we will be incrementing the count for that particular query. Nothing but we are counting colors here. Count colors. So that is what we'll be doing in fifth step. After fifth step, after counting of the colors, what we have to do? We have to output the result. Nothing but after processing all queries, we have to print the number of colors that connect the two vertices of each query. That's what we have to determine. We have to determine how many number of vertices connect the each query, right, of different color. So we will print the number of colors that connect the two vertices for each query. So here in simple terms, it is we have to output the result. So for printing, we'll be making use of console log. As we are making use of JavaScript or the Node, we'll go with this one, console log, and we will be printing the number of colors that connect the two vertices of the each query finally after counting the colors, right? So this is the approach that we will be going for this particular problem. So let me delete this one. Let's start writing the code so that we will understand this one clearly. So let's start by importing the fs module to handle the input from the file system. I'll just give here const fs equals require of fs. So this is fine. Next, let's read the input. Also trim the white spaces. Means if there are extra spaces, then we will trim. Then we will remove that one by making use of the trim. Also, we have to read the individual lines of input, right? Line by line. So for that purpose, I'll be making use of split. So how can we write that? Here, I'll just be giving const input equals fs dot read file sync. We'll start from 0 and we'll set the encoding to UTF-8. This is one thing, and we have to remove the spaces, right? For that, I'll just be making use of trim. Also, we have to read individual lines, so I'll just be giving split slash n. So this is fine. Next, after this step, we have to initialize the count to keep track of the current line that is being processed. Nothing but we are starting from the 0, right? First line input. So I'll just give here let count equals 0. Also, we have to extract the number of vertices, that is n, and edges m from the first line. Nothing but in simple terms, we are extracting the number of vertices and edges. So how can we write that? I'll just make use of the destructuring operator. And comma m, I can just give here input of we have to increment here, right? We have to move to the next this one vertex or this one node. So to get the if we have the same, if we have the distinct numbers in the same line, we are going with the space between them. For that purpose, I'll be making use of split. Also, it will be of we are making use of the number over here, right? So we'll map all the number of the type number. We can also make use of the big int here if we are dealing with very large numbers or large inputs. So I'll just make use of the number for now. So number is enough, I think, here. So next step, what we'll do, we will create the graph where each color has its own adjacency list. We'll be storing that one in the 3D array. So I'll just give let crash equals, let's create the new array of size m+1, and let's fill this array with 0 initially, and also map all the elements, right? So here I'll give array of size n+1. Let's fill this one with 0, and again let's map this one square braces. This is fine. So after this step, what we will do, after we have done the we are done with the initialization part for now, right? So next, let's go with the iteration. So I'll just give equals 0 less than n. This has to be, I have considered this one m, right? This has to be I less than m. So next step, let's read each edge with the vertices A, B and color C. So we have the vertices A and B, and the edge we are reading the each edge between the vertices A and B, and color we are considering it as C. So how can we write that? I'll just make use of the destructuring operator so that I don't have to initialize one by one, right? Rather than I can go in a single line. I can write this one in a single line. So I'll just give input of, let me increment the count. Also, if we are having the distinct numbers in the same line, we need spaces between them. That is the reason I'll be making use of split over here. Again, I'll just make use of math, and it will be of type number. So we'll be making use of number, right? So it will be of type number. So next, let's add the vertex B to the adjacent list of vertex A for color C and vice versa. So I'll just give here vice versa. So I'll just give here graph of C and A. So this one for adding, I'll just make use of push directly in the JavaScript. So here I'll just give graph of C, D. Let's make use of push here, A. This is, I hope this is clear till here. Next, after this step, we have to read the number of queries, right? How many number of queries are there? That we have to read. Also, after reading the number of queries, let me initialize an array. Why we have to initialize the array? To store the results of each query. So we are storing the result of each query. Means how many number of vertex with the different color that can be connected between two nodes or vertices, that we need to calculate, right? So for that one, we need to store that one, store the result for the each query somewhere. So for that reason, I'll be initializing an array. So let me give here first initially, let's read the number of queries. So here, I'll just take this one of type number. It will be input within the array. Let's increment the count. So let me give this one. Let result equals this one. After this one, let's start the iteration. I less than q. Let's increment the I. This is fine. After this one iteration, let's make use of the destructuring operator u comma v. This one will be input of, let's increment the count, as well as let's make use of the split and leave the space for distinct two distinct numbers. And let's map this one again of type number. Also, let's initialize the colors to 0. Nothing but we are initializing the counter for the number of colors that connect U and V. So next step, we are done with the initialization. So next, let's go with the iteration part. We are looping through each color from 1 to m. So how can I write that? So here, sorry, I'll just start the for loop here. For 1 to m we are doing, right? This will be 1 I. It has to be less than or equal to m. Let's increment the I. So next, let's create the visited array to track which nodes are visited for this color. So I can write this one in this way. Let visited equals new array of size. I can just take n plus 1 and let me fill this one with initially Boolean value false. So after this, as we had discussed in the approach, we'll be going with the DFS. In this case, we'll start the DFS from vertex U, nothing but node U. We are making use of stack over here. So we'll start the DFS from node U, right? So after starting from the node U, starting DFS from the node U, we'll mark U as visited. So I'll just give here visited of U, and we will check this one to Boolean value true. So I hope this is clear till here. So next, if there are nodes in the stack to process, then we will pop the top node, pop is nothing but we are deleting the top node from the stack. So this has to be true, right? We should have the some length in the stack. So I'll be making use of while while stack dot length. We need to pop the top node from the stack, right? So I'll just make use of node equals stack dot pop. So this is one thing. Then finally after this, what we'll be doing, we'll be exploring all the neighbors of node for the current color C. So let's explore all the neighbors of node for the current color C. So for this one, again, I'll be making use of loop. So for loop, right? So how can I write this one? I'll just write let next of graph C and node here in this case. So this is fine. After this part, what we'll be doing, just give me a second. So if the neighbor hasn't been visited yet, so if we haven't visited the neighbor yet, then we will mark it as this one, visited. How can we write that? So either I can write visited of next equals undefined, or I can write in this way as well, right? If not of visited of next, then I can write, then we'll mark it as visited, nothing but visited of next. We will set this one to true. So this is fine. Next, after marking this one as visited, we have to push the neighbor onto the stack to explore it further. So for adding, or I'll just make use of the push, right? For adding the neighbor into the stack. So I can just give stack.push of next. So I hope this is clear. This is easy, right? That was easy. And after this step, if the vertex V is reached using this color, I mean from you, if the vertex V is reached using the particular color, then we will increment the count of that particular color. So in this case, I can just write if visited of V, then we can just increment. We have to colors, I think, right? Yeah, colors. Let's increment this colors. So this is fine. Finally, after this step, we have to store the result for this particular query. Then how can we store the result for the query? I can just write, I have to result itself, right? res push of here it will be colors. So now we have got the output. So we need to display the output. So as we are making use of the JavaScript, I'll just go with the console log to print or display the output. So output is result. Also, we have made use of the split. So let's join, and also we need the output in different lines. So I'll just go with /n. So this is it. I hope this works. Let me come here. Let's check with the different input. So we need to get output 2, 1 and 0. So here, if I click on this one, run. So we are getting some error, right? Line number 7, malformed arrow function parameter list here. Graph equals new array of m+1 of 0 dot map of n+1. So here, this one, just give me a second. So yeah, what this is saying is here, malformed function parameter list, right? I have forgotten the braces over here, bracket. I mean, here, we have to provide one more braces over here, right? So I had forgot this one. Let me run this one again. So we are getting node internal FS encoding YTF8 field. So this has to be UTF-8, right? So did I type YTF? This is fine. Let me run this one again. So yeah, now we are getting the output 6, right? So this has to be 210, but we are getting the output 6. Let's check for the one more, this one. This one has to be 11112. So both will get the round output itself. So 6 and 8 we are getting. So this is wrong. Somewhere we have done wrong. Let's check where we have done wrong. So what I have done wrong here is in the line number 22, you can see here I have considered let c equals 1. Here it has to be c less than or equal to m, right? And we are incrementing the c. So instead of c, I have made use of the I in a hurry, I think. So this is fine. Let me run this one again. So yeah, now for the second input, we are getting the correct output, right? 11112. So this is correct. Now the code is working properly. So let's check for the first input as well. We have to get the output 210. So I'll just come here. Let me hit the run button. So we are getting the output 210. So this code works absolutely correct. Just give me a second. So I'll just come here. Let me click on submit code. So I'll choose the problem F, Mr. Kitayuta's colorful graph, right? So I'll just paste this one over here and hit on submit. So let's wait for some time. Then so here you can clearly see this got accepted, right? So yeah, you can clearly see here this got accepted and this code works absolutely correct. So I had just there was some typos here. Instead of UTF I had given by TF. Also here in the loop and the line number 22, the main problem was here instead of c less than or equal to m, incrementing the c. So I had made use of I. This was completely wrong, right? So that's why we were getting the wrong output. So now this works absolutely correct. Also here I had made a mistake. I think I had missed the braces over here in the line number 7. So these 3 mistakes, this is fine. Now the code works absolutely correct. This is it. Thanks for watching, guys.